Well, welcome to this month's Ask Your Herb Doctor. My name's Andrew Murray.
My name's Sarah Johannesson Murray.
For those of you who perhaps never listen to our shows, they run every third Friday of the month from 7 till 8 p.m. We're both licensed medical herbalists who trained in England and graduated there with a degree in herbal medicine. We run a clinic in Garberville where we consult with clients about a wide range of conditions and recommend herbal supplements and dietary advice. This month we want to reassess the role of sugar in the diet and why good sugars are essential for good health. It seems that many things we are told are bad for us are actually the good guys, and we need to see the facts and research that's out there. First it was saturated animal fats, and we were told they were hardening our arteries and leading us into an early grave. Well, not true. The polyunsaturated alternatives are actually damaging us and are the cause of many disorders. Then salt, which we were told was increasing our blood pressure. Again, not true. Salt's essential and regulates many processes without which we suffer from increased adrenaline and stress hormones. Now sugar, it's the bad guy. Well, not true. So once again, we're excited to have Dr. Ray Peat with us this month, and we'll be hearing from him on research-based facts behind the statement that sugar's good for you. So, Dr. Peat, thank you so much for joining us again. Would you first give the listeners who perhaps have just tuned in and maybe never listened to the show or never heard you on our shows before, a little bit about your background?
Okay. In the 50s and 60s, I was studying and teaching in the humanities, but I spent a lot of time reading at the science library of the University of Oregon, and so I eventually decided to get a PhD in biology, physiology, so I could use their laboratory equipment as well as their library. But I never really considered myself part of the academic, scientific community. I just got what I could from their culture, and have tried to see things that are useful rather than just abstract, and that has meant that I concentrate on small molecules rather than genes and the big fancy molecules. So water, carbon dioxide, salt, calcium, sugar, and fats have been the things that I study most.
Okay, well, perhaps, Dr. Peat, would you first qualify the term good sugar for our listeners, and then we'll get into the facts and figures, as it were, surrounding sugar and why they're so important for us?
Sugar is really the ideal energy exchange substance. It's useful for all organisms practically, and it's something that we can store and turn it into, use it for building all of the big molecules, and when it's metabolized, it releases carbon dioxide. And carbon dioxide is really a more universal substance than oxygen for the support of life.
Mike, you had told us in one of our previous shows that there are organisms who can live without oxygen, known as anaerobic organisms, but there are no organisms that can live without carbon dioxide.
Right, and it turns out that it isn't just mosquitoes and fleas and bed bugs that are attracted to carbon dioxide, but the flatworms and nematodes and such that they're studying as simple models of metabolism and aging. They seek out a fairly high concentration of carbon dioxide as more favorable for their living conditions.
So as our cells use sugar more effectively, then are we producing a larger amount of carbon dioxide?
Yeah, and when we produce more carbon dioxide, that means we inhibit the production of lactic acid, which is not only a wasteful way to use sugar, but lactic acid has a signal function that turns on a whole range of inflammatory processes, and they have talked for decades about tumors producing lactic acid, but lactic acid also promotes tumors and all of the inflammatory processes. So you want your sugar to metabolize into carbon dioxide, which will then prevent the dangerous overproduction of lactic acid.
And can somebody overdose themselves on lactic acid from eating fermented cultured products?
Yeah, I got interested in that a long time ago when I found a nice kefir product that tasted good, and I would drink a pint of it for lunch. And I came down with a migraine every time I did that, and that caused me to read more about the metabolism of lactic acid. It is normally produced by stress when you use your muscles faster than your lungs can keep the oxygen supply adequate. The lactic acid is circulated into your bloodstream, reaches the liver, and your liver has to spend extra energy to turn the lactic acid back into glucose, which it then sends back to the muscles. But meanwhile, it's depleting your liver of any stored glycogen it had just to get rid of the lactic acid and turn it back into glucose. So
it's wasting the sugar that your liver has stored as glycogen.
Yeah, and I happened, because I probably was hypothyroid, I happened to be so sensitive that I got a migraine just from drinking a package of the kefir.
Because the lactic acid was actually lowering your blood sugar then.
Yeah, and since then I've run into quite a few people who were having various symptoms every time they ate a fermented product with lactic acid in it. The vinegar type fermentation it's slightly toxic, but it doesn't participate in that blood sugar disturbing effect that lactic acid does.
Right, so it's all the probiotic.
Well, yeah, some of the probiotic bacteria that make lactic acid in themselves, they can produce other substances that are protective, but you don't want them producing lactic acid from the sugar you eat. The sugar you eat should be absorbed up in the first part of your intestine where there are no bacteria to speak of.
Or there shouldn't be, right?
Yeah, and for various reasons, sometimes the bacteria will migrate up there from a sluggish bowel and so on. Or if you eat poorly digested materials like too many starches or fibrous mixtures of starch and carbohydrates, these things will not be absorbed, and so they'll go down and feed the bacteria, and then the bacteria can make lactic acid and other worse toxins from them.
Okay, I think it's important that a few moments ago you mentioned the fact that glycogen that's normally stored in the liver as a storage form of sugar is used to convert lactic acid when it's been produced in the absence of sufficient oxygen from muscular activity to create the conversion of lactic acid back into glucose. And what I wanted to just bring out is that for most people that are listening, perhaps who may not understand it, but that the liver is a good storage organ for glycogen as a form of sugar to be used in times when it's needed. But would you expand on that in terms of how much glycogen is the liver able to store? How long do people have
before they have to, or how long can people go with just eating proteins or not eating before their liver goes, okay, I don't have enough, and then they start eating themselves.
This brings out why sugar is big. It will start to bring out why sugar is good, and then we can keep delving into the details and the facts.
If your thyroid and other hormones are in the right concentration, your liver should be able to store at least 8 hours of glycogen, so that everyone should be able to get through the night on the amount of glycogen in their liver without resorting to other sources of energy. But when your thyroid is a little low, or, for example, if your estrogen is too high, or other things are interfering, then your liver sometimes can hardly store any glycogen. And typically, when your glycogen runs out, you send out a surge of adrenaline, which will squeeze the last little bit of glucose out of your liver. It activates the dissolution of glycogen, turning it into glucose. And when your liver can't respond to the adrenaline anymore, the first sign of depleted glucose is you might feel shaky and cold from the high adrenaline. Then you resort to increased cortisol, which begins breaking down your tissues, turning protein into fat and carbohydrate for energy. And under that extreme condition, when you've been out of glycogen long enough to run on cortisol for about a day, your thymus will be dissolved just in a few hours of the intense exposure to cortisol. And when the quickly dissolved tissues, such as the thymus, are gone over the next week or whatever it is that you're not replenishing your sugar, your muscles will atrophy. So that people who fast for a week or two will usually lose more muscle weight than they lose fat because of the very rapid conversion of protein into fuel.
Under the influence of the cortisol.
Yeah. So whenever you eat a big dose of protein without sugar to back it up, you're going to stimulate the secretion of first insulin to dispose of the digested amino acids from the protein, and the insulin, which properly disposes of the amino acids, is going to lower any circulating glucose and tend to turn it into fat. And as the glucose goes down, that will drive up your cortisol. So typically a big protein meal will cause a huge surge of cortisol, and some people become supposedly diabetic or very hyperglycemic because they eat too much meat unaccompanied by sugar or some carbohydrate.
And that's just because the protein is stimulating the cortisol, and the cortisol is...
Yeah, it's doing its job of
metabolizing
turning protein into sugar and fat.
So it's important to keep a balance between proteins and sugars. And
we should always eat sugars with protein.
Right, and just for our listeners to clarify, sugars, carbohydrates, we're using the term synonymously. Sugars and carbohydrates are basically the same thing. There's different types of sugars or different types of carbohydrates, starchy carbohydrates versus non-starchy carbohydrates. And I think we're going to get into that a little bit later. But
Okay, well, you're listening to Ask Your Herb Doctor on KMUD Garberville 91.1 FM. And from 7:30 until the end of the show at 8 o'clock, you're invited to call in with any questions, either related or unrelated, to this month's topic of sugar and the benefits of sugar. The number here, if you live in the area, is 923-3911, or if you live outside the area, the toll-free number is 1-800-KMUD-RAD. And we are excited and very pleased to have with us on the show today Dr. Ray Peat, endocrinologist and research scientist, who is going to unravel some of the myths and some of the truths about why sugar is good for you. So, Dr. Peat, perhaps we should break into the good sugars versus the bad sugars, because obviously most people have heard in one form or another that sugar's bad for you. So let's clarify the bad sugars versus the good sugars and what they are and what food sources they are in.
One of the things that started me thinking about whether a person should follow the government's advice to eat a lot of starch.
Complex, otherwise known as complex carbohydrates.
Yeah, the government and the American Dietetics Association, I think it's been almost 50 years, have been promoting that idea that complex carbohydrates have some advantage over sugars. And I started reading about that in the 70s and ran across Gerhard Polkheimer's research, in which he had first fed different mixtures of starch and water, cornstarch, potato starch, and several other kinds of starch, which occur in grains that are roughly the size of a cell, anywhere from 5 microns in diameter up to 100 microns. And he would feed these to his experimental mice and then sampled their body fluids. And he found that a chronic diet was of frequent feedings of the starch solution was he could demonstrate the particles of starch in their bloodstream just minutes after they ate it, and then in all of their body fluids about an hour later. And so he fed that sort of a program to his mice for several months and found that they were prematurely aged. And when he sliced them up, he found in all of their organs little nests of dead cells where one of these fairly large grains of starch, roughly the size of a red blood cell, was stuck in an arteriole, killing all of the cells downstream from that plugged up point.
So the starch granules were blocking the arteries and starving the cells, or the arterioles, and starving the cells of the nutrition from the blood.
Yeah, and so he tested it on his medical students and would draw blood and sampled their urine and found that about 30 minutes after you drink some of it, you can find starch grains in your veins. 45 minutes to an hour later, you find it in the urine and in the bile and even in the cerebrospinal fluid about an hour and a half later.
And they're not supposed to cross the blood-brain barrier, are they?
Well, they aren't supposed to cross the intestinal barrier, but...
because they're so small? I mean, is this just...
This is so large.
Is this because people's intestines are completely out of balance, or is it just the nature of the size of the starch granule?
He assumed and proposed that they're being forced between cells, but people have such a mechanical conception of how the wall of the intestine and the arteries and veins and capillaries, how they're constructed, that it just seems mechanically impossible, but it's actually more like a viscous fluid, and things can really sort of migrate through things as if there was no absolute barrier.
So it's like a mesh.
Yeah. Many years ago, someone made a movie of white blood cells and showed them what looked like freely swimming in and out of cells, swimming into a cell and looking around behind the nucleus and poking around and then leaving the cell.
As the guards of the blood.
Yeah. And people don't draw conclusions from that there aren't cell walls that have to be broken. It's more like a sort of viscous fluid
through which all these communications occur.
Yeah.
Okay, so let's list the good sugars and then the bad sugars, just to keep that in context.
Well, so Dr. Peat's already mentioned the starches as being the bad guys because they're blocking arteries, but there's other things that starches do that aren't so great for your...
Yeah, the typical starch, when it's cooked and digested, if it isn't digested, then it goes down and feeds the bacteria, and that's a really bad effect. They've seen with these so-called prebiotic or probiotic semi-digestible starches that are being promoted. They have found that the poorly digested starches cause behavioral changes in their animals, makes them anxious and aggressive to have stuff fermenting in their intestine. And some of the products of bacterial action on these undigested materials can tremendously increase endotoxins and cause inflammation of the intestine, liver, and eventually all of the body. But the typical well-cooked starch, when it is digested, releases pure glucose. And in my first physiology lab, professor had us feed, I think it was a 10-gram dose of cornstarch to the lab rats. And she said, wait 10 minutes and then operate on the rat and see how far this huge glob of starch paste had migrated. And it turned out that there was no trace of any starch paste left in the rat after 10 minutes.
Well, it was all picked up.
It had just instantly been turned into glucose and absorbed. And we aren't quite as fast as rats, but when you look at the so-called glycemic index of foods, starch tends to be near the top, right, very similar to pure glucose. And that means that you get a quick, powerful stimulation of insulin when you eat starch or plain glucose, and that the insulin does its work quickly of disposing of the glucose by turning it into fat when you absorb more than you need.
But then your liver is, if it's turned into fat, then it didn't really store very much in your liver, right? Yeah,
it does that too, but when you have this very intense dose, some of it goes into the liver, but if it can't all momentarily be disposed of in the liver, then some of it turns into fat. So even though you aren't eating too many calories, if you eat it in the form of very quickly digested starch or pure glucose, you'll get these bursts of fat synthesis and tend to get fatter and fatter. And because the same thing that happens with a quickly assimilated glucose or starch, the same thing happens as when you eat a pure protein meal. The sudden falling of the blood sugar causes a surge of cortisol production, and then that changes your metabolism, makes you waste protein. Even if you didn't eat any, you'll then disturb some of your tissue, your thymus and muscles especially. And so the cortisol helps to direct the fat deposition to your waist area and back and face, as in Cushing's syndrome, or the so-called metabolic syndrome.
So whether you eat a meal that has pure protein or whether you eat a meal with protein and starch, the end game is going to be the same. It's going to drive up insulin. It's going to drive increased fat production. And it's not going to be storing sugar in your liver as effectively as it could be if you were eating a different type of sugar.
Yeah.
So what types of sugars are slow release and are stored in your liver as glycogen so that your body can have an instant supply of sugar?
Sucrose, glucose, fructose, and lactose are very good, well metabolized sugars.
And do those sugars feed bacteria in the lower?
Well, they're so quickly absorbed that usually they will be absorbed partly in your stomach and partly in the first foot or so of intestine. And the presence of fructose partly blocks the release of insulin and partly changes the effect of insulin so that it helps to direct some of the glucose into the liver while blocking its storage as fat. And so you get a lower secretion of insulin, a lower stress effect, and a better glycogen storage effect from either sucrose or the mixture of glucose and fructose, or in the case of milk and milk sugar, the presence of the proteins and fat in the milk add to the slowing of the sugar effect.
I wondered how many grams of sugar would you say would be a good, healthy amount? Because I know definitely with things like calories, they're pretty well understated by government standards, as are several other levels of certain nutrients, etc. But what would you say as an intake of sugar would be a good, healthy intake?
Well, it depends on your total caloric requirement,
right.
And
right.
Some, especially hypothyroid women, can maintain their body weight on 700 or 800 calories a day, and textbooks used to say that you had to lose weight if you ate less than 1,600 calories a day. But now many people, especially women, can get fat on 1,500 calories because of things interfering with their metabolism and thyroid function. But if you have a healthy metabolism and can burn between 2,000 and 3,500 calories a day, then your carbohydrate requirement is going to be somewhere in the range of 180 grams to 350 grams.
And just to give people an idea of how many grams of sugar are in different foods, 1 teaspoon of sugar contains 4 grams of sugar. So it's actually not very much. You might think 1 teaspoon of sugar has a lot. And if you need 180 minimum per day to keep your liver happy, in comparison, 1 cup of brown rice contains 41 grams of sugar. But the glycemic index of the rice is going to be a lot higher than it is of the sugar. And so you'll store the sugars from the rice a lot more as fat than you would as if you were eating the same amount of grams of sugar in actual white sugar.
And when you get your sugars in the form of more natural foods rather than refined white sucrose, for example, if you eat orange juice and milk, the orange juice is extremely rich in minerals compared to rice or any of the popular pasta, bread, and so on. Those are very poor in the minerals that orange juice and other fruits provide richly. And potassium, which is very abundant in all fruits, acts like insulin, so you don't have to secrete very much insulin for the same disposition of glucose. And the orange juice also has some other helpful chemicals like naringin and that help to prevent inflammation and increase the good disposition of the carbohydrate. And in milk, besides the protein and fat, slowing the absorption of the lactose. The calcium is, besides the potassium and other minerals, the calcium powerfully stimulates the energy metabolism, causing you to use your sugar more quickly, preventing it from being stored as fat. So the milk drinkers, in general, tend to be much slimmer than non-milk drinkers, largely because of this effect of calcium.
So there's more than just insulin to the way you store sugar, but potassium and calcium have an effect on your use and storage of sugar as well.
Okay, you're listening to Ask Your Herb Doctor on KMUD Garberville 91.1 FM. And from right now until the end of the show at 8 o'clock, you're invited to call in with any questions, either related or unrelated to this month's topic of sugar and the benefits of sugar. The number, if you live in the area, 923-3911, or if you live outside the area, the toll-free number is 1-800-KMUD-RAD. Okay, so to continue with the good benefits of sugar and why it's so maligned.
Well, so Dr. Peat, can you explain to us, so you've mentioned milk and orange juices being good sources of some natural sugars. What about honey and lots of other fruits?
Honey is generally better than white sugar because it has some minerals, but not as much as in the fruits. And it's probably the best refined. The bees refined it rather than a factory. But honey has been used as a food by all of the high civilizations. I think there's good reason to think that sugar goes with high cultural development. The Egyptians and Chinese and all of the old, well-developed cultures knew about honey, and most of them also refined sugar. The Arabs were the pioneers. The Egyptians were actually refining sugar from sugarcane probably a couple thousand years ago.
Okay, sorry. Do we have a caller?
No. I was just wondering if you guys were hearing me on that. That call or not. It was okay.
No, sorry. Okay, well, we hear you now, Marianne. Thank you.
Okay, so going on to previous cultural experience with sugar, the Egyptians and other civilizations have certainly benefited from sugar and held it in high regard, like they did salt as a form of currency for trading with neighboring civilizations. So the current dogma of sugar being the bad guy and being responsible for cavities and increasing diabetes and obesity, can this pretty much be explained from the processed, refined sugar that we're talking about tonight, with things like pastas and white bread and those other sources of instant release high glycemic index sugars versus
and low mineral sugars.
And low mineral sugars, yeah. Versus sugars that come with a complement of other minerals and other chemicals, things like honey and then the fruits. Are there any other sources that people should be aware of that are certainly going to encourage people to use rather than tell them they shouldn't be using sugar?
I think you've about covered it all, Andrew. Do you have any more sugars to add to the list, Dr. Peat, that you'd say are the good guys?
No, nothing occurs to me.
Okay. So how about the, for people that are listening now, what's the deal with diabetes and sugar and that link and how that link is not necessarily true?
The principle in physiology that I think really explains it was proposed a few decades ago. It's called the Randall effect or the Randall cycle, although there's no cycle involved. That refers to the fact that free fatty acids block the use of glucose by cells. And that was demonstrated frequently in hospitals when they were giving nutrition support to people who couldn't eat or cancer patients who were losing weight very fast in the form of a soy oil emulsion. They saw that about 15 minutes after injecting this nutritional dose of emulsified soy oil intravenously, that people would get hyperglycemic. And the Randall effect is sort of an instantaneous thing, but when the fatty acids that are involved in blocking the use of sugar, when those are polyunsaturated, they produce long-range damage that keeps the Randall effect going, keeps blocking the use of sugar. A group, I think it was in South Carolina, the lead author of one of the papers was MX Fu, who showed that the glycated proteins that are seen in diabetic people, that glycated hemoglobin, for example, and they blame that on glucose or fructose fragments sticking to hemoglobin and other proteins. But Fu and his group demonstrated that polyunsaturated fatty acids are much more powerful glycators, sticking fragments, 3 carbon, 5 carbon, and longer fragments from the spontaneously oxidized polyunsaturated fats stick to the proteins. And so the free fatty acids not only block the sugar use instantaneously, but they produce these advanced glycation end products, the AGEs, that are associated with diabetes and aging. So the chronic effect of a high-fat diet, if the fat diet is predominantly unsaturated, produces not only diabetes but all of the things that result from glycated proteins.
So in diabetes, people are poisoning their pancreas with these polyunsaturated fatty acids, blocking the pancreatic beta cells from producing insulin. But then they're also, they have these high levels of free fatty acids that are blocking the sugar getting into the cell. And then doesn't that feed back to the system to tell the body, raise the blood sugar higher, we're not getting enough? It's
a self-stimulating system. So when you block the cells from using glucose, they call for more glucose, and the liver obliges by making extra glucose when it can, mobilizing it.
And going back to the starches you've already described more strongly stimulate insulin than the simple sugars do that come from fruits and honey. So wouldn't that be more contributory to the theory of wearing out the pancreas?
Yeah, and the diabetics, supposedly the sugar just isn't getting into their cells, but what's happening, you can see in the fact that diabetics often have very high lactic acid concentrations. showing that the glucose is getting into the cell, but it just can't be used oxidatively because of the fatty acids blocking the respiratory system. So then the lactic acid goes to the liver, which turns it into more glucose.
I wanted to ask you in a little while, because we have a caller on the line, about your opinion of high fructose corn syrup, but let's take this caller first. Are you on the air?
Hello?
Hello, you're on the air.
Hi. I'm wondering, because some of the stuff I understand, some of the stuff I don't understand. Okay, so if I eat a big bowl of cereal with a lot of sugar, and then 2 hours later I get sleepy, what does that mean?
Usually, it's the same effect that a person who has been hypothyroid experiences when they correct their thyroid. When your adrenaline is high, you're being stimulated.
You're very alert and aware and on edge. Your body's under the stress hormone adrenaline. It's ready to go, and you feel wide awake.
And when you either correct your thyroid function or whatever other glandular process is causing you to have high adrenaline, or if you eat a lot of sugar, sugar and salt will both help to lower adrenaline, and so they can both make you sleepy while they're present and circulating. So people who have insomnia can take care of the problem temporarily by just taking some sugary food and salty food at bedtime.
Okay, let me ask you another question. If a person is diabetic or pre-diabetic, is there a simple way to express what the good sugars and bad sugars are? And I'll take my answer off the phone. Thank you very much.
Did you hear that question, Dr. Peat?
Yeah. It's basically the whole thing we're talking about. The definition of diabetes and pre-diabetes they've been created to first to sell insulin and then to sell the non-insulin sugar regulating drugs and so on, and they keep multiplying the definitions of how many types of diabetes there are. There's type 1 and type 2 and syndrome X and gestational diabetes. We'll probably have half a dozen types of diabetes if the government and the medical business
get their way on.
Continue.
Okay, but basically, the good types of sugars that are going to be more slow release are the fruit sugars and the honey. And if they're eaten in combination with fat and a protein, then they're going to be even more slowly released, and they won't require the pancreas to pump out a ton load of insulin.
Yeah, fruits and cheese are very safe things for diabetics. And
they'll notice, like we've seen with our diabetic clients, that their sugar numbers don't go up with fruits and cheese and milk and honey.
I wrote a newsletter about a couple French and an English doctor 140 or 150 years ago who noticed exactly that same thing, but it didn't catch on with the medical business.
I know diabetics are told they need to eat complex carbohydrates, but when you actually look at the glycemic index of complex carbohydrates, they're much higher than what's in fruit and honey and white sugar, believe it or not.
And since the government has been making these recommendations and people have been eating more of the starches and polyunsaturated fats, the incidence of so-called diabetes has increased tremendously.
So for that diabetic caller, or if you're calling about someone else, fruits, honey,
cheese,
and dairy products, and avoiding starchy carbohydrates, which I should qualify for our listeners, are things like bread, pasta, cereals, grains, rice. All those are termed starchy carbohydrates.
Okay.
They not only have a high glycemic index, which means they shoot your sugar level up quickly, but they also have the potential to feed bacteria in your lower intestine, which causes all sorts of other problems, as maybe Dr. Peat will have time to explain. But I think we have another caller.
Another caller, yeah.
In the long range, it's very important to avoid the polyunsaturated fats for avoiding diabetes.
Right. Oh, right, yes, and sorry, I forgot to mention that for that other caller. Avoiding the vegetable oils, soy, canola, corn, safflower, sunflower, hemp seed, fish, all those polyunsaturated omega-3 and 6 especially.
Okay, so there's another caller. You're on the air?
Yes, hello?
Hi, you're on the air.
Hi. So I was wondering, what about beans and whole grains, like whole grain brown rice, that kind of thing? Because you mentioned rice, but were you specifically talking about white rice or with the whole grains?
Well,
like quinoa, things like that, and beans. What about, and also, a lot of different nutritional people claim that there's a problem when you combine like fruits with proteins, and they want you to separate them by a couple of hours, things like that. But what you're saying seems to contradict that theory. And so I was wondering,
I think it's good to precede a big protein meal by maybe 15 or 20 minutes with fruits, so that you get your liver stocked with some glycogen, so that you don't respond so violently when you eat a pure protein. And the whole grains and legumes are, they have more nutrients, but only a small amount of the minerals compared to the fruits. And the germs do contain some valuable nutrients, but they also contain enough of the polyunsaturated fats in the germs that was why the refining was invented by the Chinese several thousand years ago, because they found that the rancidity of the whole grains damaged the nutritional value.
Oh, well, that's it. So then it sounds to me like you're saying that a person should, a good diet would be mostly fruit and then protein and then maybe some of the other stuff. But staying away from the polyunsaturated oils and even the omega-3 oils that they keep telling you to concentrate on.
Yeah, their virtue is that they're a little less toxic in the sense of causing cancer than the omega-6, but they tend to break down faster even than the omega-6, and their main virtue therapeutically is as an anti-inflammatory agent. That's why they're becoming popular for arthritis and
psoriasis.
But the way they're anti-inflammatory is that their breakdown products interfere with the immune system and stop the inflammation in the short run, but in the long run, they're suppressing your immune system. And
is that like cortisone or something?
Yeah, very similar.
Uh-huh. So then if you wanted to have, you should stick with things like fish oil and stuff rather than the...
Well, the fish oil breaks down very easily too, so in the long range, it has its serious problems too.
A better solution would be to find out what's causing the inflammation in the first place. Is it a thyroid deficiency or another hormonal imbalance that's causing your inflammation, rather than taking fish oils to just block it? Because even radiation they used to do radiation treatments to help people's rheumatoid arthritis because it was anti-inflammatory.
Wow. Well, do you and I guess that's your husband that practice together?
Yes,
is that right?
My husband is Andrew, and I'm Sarah.
Yeah. Do you guys do, can someone come to you and get, an evaluation of their system so that you know where your deficiencies are?
Yes, we do offer consultations, nutritional and herbal consultations, and we will be giving our number out at the end of the show.
Okay. Well, thank you very much.
Thank you for your call.
Okay, I understand there's probably 4 or more callers on the line, so...
Well, that we've lost a couple. They've dropped in and out, but we do have another caller on the line.
Because it is 7:53, so there's another caller. So you're on the air?
Hello, me?
Yeah, you're on the air.
Ah, very good. Hi, Andrew and Sarah. This is Kevin.
Hey, Kevin.
Hello.
Hi. So, I have a question regarding the role of sugar in yeast infections and systemic fungal infections. And if a person has a systemic fungal infection, whether they should be avoiding all kinds of sugar.
In general, things like the yeasts that cause both internal and external infections love sugar, but they're usually about once or twice a year someone turns up who has a very intense infestation with yeast, even in their stomach, and when they eat sugar, they can actually get drunk from the fermentation, turning the sugar into alcohol. But that getting drunk on sugar is about the worst effect of the sugar metabolism by the yeast. And when you starve yeast, if you have it living in your intestine, and they're attracted to estrogen, estradiol is a reproductive hormone for yeast as it is for humans. If your estrogen is high, they tend to congregate in any place that is rich in estrogen. If you starve those for sugar, they tend to become invasive, and they put out filaments, not like the mushroom-type fungus, but a filament long enough to penetrate through cells, like fingers reaching through your intestine walls looking for sugar. And that starvation condition is what can make them invade your tissues rather than just living free in your intestine. And it's only when they invade your tissues that they can become deadly. And on your skin, low thyroid people often have high estrogen, and that favors genital yeast infections, and correcting the thyroid and hormones is the basic thing. Eating a diet that helps to regulate your hormones, and topically just dusting with sulfur powder, flowers of sulfur or precipitated sulfur is a safe way to kill them on the surface. And it even works, taking a pinch of it orally will suppress the fungal growth inside the intestine.
Oh, great. Okay.
So are you saying, Dr. Peat, that if someone does have an overgrowth of fungus in their intestines, that actually eating more sugar would feed the yeast and make them happier, so they're less invasive and less deadly?
Yeah, actually.
And what would you suggest be a treatment, a good treatment for that? Well,
the carrot salad, the carrot is indigestible, and you know how a stale carrot takes weeks and weeks before it molds or never rots, really.
That's true.
And, that's because it has antifungal, antibacterial chemicals in it because it lives in the ground.
Okay.
And so if you grate a carrot and then put some oil, olive oil or coconut oil, and vinegar, vinegar is a bacterial chemical. The acetic acid is the bacteria's way of killing fungus, and it's a short saturated fatty acid, and so the longer fatty acids of coconut oil and olive oil are bound to this indigestible fiber of the carrot and slowly released all the way down your intestine. And they have a very profound, safe, disinfecting action on your intestine that will take care of not only the fungus but a lot of bad other types of organisms.
Okay, good. I think we'll have to call it a night there. So make sure that people get your contact information, Dr. Peat. Thank you so much for all the callers who have phoned in this week, and thank you so much for listening to the show. For those who would like to find out more about Dr. Ray Peat, his website is www.raypeat.org.
No, .com.
Sorry, .com now. It's .com. Beg your pardon. Gosh, I get that wrong so often. It's .com. Okay, so raypeat.com, RAYPEAT.com. So?
I was just going to spell it out, RAYPEAT.
Okay, he's got a very informative website with a lot of scholarly research articles that are all fully referenced from those topics that he first introduced himself for, things like salt, the polyunsaturated issues, hormone-related issues. Has some articles there on cancers and their genesis. It's a very good site, well worth looking out and finding more from. Okay, so we can be reached toll-free, 1-888-WBM-HERB, for consultations or further information Monday through Friday. And thank you so much to all of you who listen regularly and those who tuned in this evening. To those who have ears, let them hear. Good night.
Please remember that this program is supported by the listener members of Redwood Community Radio. If you like what you hear, please consider becoming a member of KMUD or renewing if you've already joined. A regular yearly membership is $50, but we accept any amount. Help us keep free speech alive. Please remember that this program is supported by the listener members of Redwood Community Radio. If you like what you hear, please consider becoming a member of KMUD or renewing if you've already joined. A regular yearly membership is $50, but we accept any amount. Help us keep free speech alive. Please remember that this program is supported by the listener members of Redwood Community Radio. If you like what you hear, please consider becoming a member of KMUD or renewing if you've already joined. A regular yearly membership is $50, but we accept any amount. Help us keep free speech alive. Please remember that this program is supported by the listener members of Redwood Community Radio. If you like what you hear, please consider becoming a member of KMUD or renewing if you've already joined. A regular yearly membership is $50, but we accept any amount. Help us keep free speech alive.